Okay, so now let us discuss some examples related to hypothesis testing. So we know the basic examples, like for example, uh, okay, so now let us discuss the examples. Like previous we discussed, we identified the drug and we say that it has no effect on the blood sugar. So which is, oh, okay, okay. So we discussed that the drug is not showing any effect on the blood sugar. So that comes under the null, and we said that the drug is showing some effect on the null, like on the blood sugar, whether it can increase or decrease. So it is the alternate. That are the basic examples that we discussed. Now let us discuss some more in-depth examples so that you can understand what is null, what is alternate. Okay. For example, you consider like the average age of student at an unnamed university has historically been 23 years old, like with a standard deviation of 2.4 years. For example, if you consider the average age of a university, which is 23 years old, and there is a standard deviation of 2.4 years. And this semester, so which comes under the sample. So that is the population, and this will comes under the sample. So this semester we asked 42 random students and their age, and we received an average of 23.8 years. So in this semester, it came to know that the average age of the students is 23.8. So now we need to decide like whether it is significant or not, because past it is 23 years old, but this semester it is 23.8. So is this significant or not? We need to perform the test. So here comes the test. So Z or T, the population variance is known. Yes, we know the population variance, right, of the population, which is the standard deviation is 2.4 years. If we square the standard deviation, then it is variance, right? So we know the population variance. The sample size is greater than 30 because we considered 42 random students, so which is greater than 30. So which test we are going to use? And we use jet test because the sample size is greater than 30. And okay, these are the steps you perform, like you consider before doing the hypothesis testing. So the first step is you need to set the H naught and H1. So what is the H naught? So H naught is the given one. So the mean age of the students this semester is not significantly different from the historical mean. So we say that like in H naught, we simply consider nothing is happening. So we say that they are not significantly different. But in H1, like we may consider the mean age of this semester, it is not equal to 23 years. That is the H1. And step two, we need to set the significance level. Okay, let's try two different one. Okay, so let us try with alpha equal to 0.05, which is 95% confidence interval. So we are testing, like therefore we want a two-tail test, like 0.05 on other side. So the thing is, like we consider alpha equal to 0.05, and if you consider 2a, that is 2 into 0.05, which is like 0.2550. And here we are going to use the jet table. So based upon the jet table, you will decide the values. So for example, let me. So this is how a jet table will look. And you will find the values. This is the jet values based upon the values that you got. So we got how much? Okay, it's 0.0250, and you will see this value in the Z table. Like for example, Like for example, if this is the value 0.0025, like for example, if you consider this is this is your value, and here we have the z values as 0.28 and this is 0.21. So like you need to read the critical values through like three decimal places using row and column. So let us see the actual values. 0.0250, where it is 0.02. Yes. So here, this is the value 0.0250. For this, if you observe, it is minus 1.9. And here, if you observe the column value, it is 0.06. So we'll consider the row value that we got from the table and the column value from the table. So which is 1.96. The negative, like negative sign indicates the left side. So here from the Z table, you can see the two values like 1.9 and 0.06. So here we consider like positive value as 1.96 and negative value is 1.96 because we need to consider the two-tailed test, right? So we need the values for the both the regions. Coming to alpha equal to 0.02, so which is a 90%, 98% confidence interval. So how we are going to calculate this 98% confidence interval? Like in simple, you have the alpha value 0.02. So like 2 into 0.02, so which is 0.04. So you will find that value in the Z table and you will decide the left region values and the right region values. So this is how you are going to use the Z table when the significance levels are given. And step 2. Okay. So this is considering different alpha values. One is 0.05 and one is 0.02. Like don't forget that if alpha equal to 0.05, it is 95% confidence interval. And if it is 0.02, it is 98% confidence interval. And based upon that, you'll find the values. And if you see this, so these are the values from the Z table that we discussed before. So the alpha value is given, you will find the values. Once the Z value is there, you will find the like those values from the Z table, and those will be the values on the both sides of your normal distribution. So here, okay. So you got the Z values, right? In previous example, you got 1.96 and another one is negative 1.96. Now you are going to calculate it by substituting in the formula like x bar minus mu by sigma. So that is the formula to calculate the Z. So the mean of the students that we consider, the age is 23.8, right? So the x bar is like 23.8, and the mean of the sample that we consider is 23, and the standard deviation is 2.4, and that is the value that we got 0.333. So we substitute all the values in the Z formula and we will get that value. So this formula is used to calculate the Z score. That is for a single distribution. We have a sample mean. The more samples we have, the smaller the uncertainty of the mean. Like for example, if you have like more values, then you need to consider the like more values, right? Like if you see the example, so here we consider n equal to 42. In on the top we consider like n equal to 1, and in our example we considered n equal to 42. So we substituted that in the formula. You need to make a decision. So based upon the values that you got. So this is the step where you need to make a decision. So for alpha equal to 0.05, 2.16 is more extreme than 1.96. So where we got this 2.16. See, this is the value that we got for our example, which is 2.16. Now we will make the decision. So 2.16 is more extreme than 1.96. So we reject the H naught. So we conclude that we have enough evidence to be 95% sure that the mean student age has changed. So as we consider 95% confidence interval, so we are concluding like we are making conclusions for the population. And that is the reason we reject the H naught and we conclude that there is 95% confident that the mean age will be like that the mean age has been changed. And this is for alpha equal to 0.02, which is 2.16, and it is not more extreme than the value that we got. So we will accept H naught and we do not conclude like we have enough evidence to be 98% sure that the mean student age has been changed. So based upon the values that we got, we will compare and we will make a decision. And coming to the t-test, the average age of the students at an unnamed university has historically 23 years old. And this semester, we asked 12 random students their age and received an average age of 23.8 with a sample standard deviation of 2.4. The reason that we consider the sample standard deviation because in t-test, the population variance is unknown. So that is the reason we are considering the sample standard deviation. So is this significant or not? So you will find the test based upon the sample size. So what is the sample size? It is less than 30 because there are only 12 random students. And so this is like considering the null and the alternate. So the mean age of the students this semester is not significantly different from the historical mean. And the H1 mean age of this semester is not equal to 23. So the first step is completed. Let's go to the second one now. We'll consider 95% confidence interval, so which is 0.05 alpha, and we use the t table for that. So we are like we need to check the t table for the values. So there are 12 samples and the formula for the degrees of freedom is n minus 1. So 12 minus 1 is 11. So 11 will be the degrees of freedom. And so this is the t table, and based upon the t table, we need to consider the values. Okay. So here okay, so after finding the values by using the T, we will jump into the step of calculating the test statistics. So we are already using the T test because the sample size is less than 30, and that is the formula for that. We substitute the values. Not okay. So, and we got a 1.153. So what is the decision that we make? So 1.153 is not more than the extreme. So that is the value that we got before, and we got after substituting all the values in the formula, we got 1.153. So which is not more extreme than 2.201. So we accept H naught and we conclude that there is no like we do not have enough evidence to be 95% sure that the mean student age has been changed. So the process is simple. First, like decide the H naught and H1. H naught is nothing but what is given in the question. Like for example, if you get the homework on hypothesis testing, so what you need to do? First, you need to find out the H naught and next the H1. So H naught will be the simple what is given in the question. And H1 is saying that there is some effect. After that, like based upon the sample size, you need to decide which test I need to perform. So if the population variance is known, you will perform the jet test. And if the population variance is not known, you will prefer the t test. So you decide which test you need to perform. So whether it is jet or t. And next, after that, by using the jet table or t table, you'll find the values. And you'll base and next you will substitute all the values on the jet table and you will get a single score, and based on that score you will decide whether you need to accept the null or you need to reject the null. That's all. So there are only 4 simple steps. So we are done with the example. Stop recording.